Hi, we are still solving linear systems algebraically. We saw elimination method earlier, elimination by addition. That was lesson 9. We are continuing to learn elimination method, but this time we're going by multiplication. In 9.3 we did elimination by addition and we used property of equality, which made it possible for us to eliminate a variable. So now we are going to use the multiplication property of equality, which will make it possible for us to eliminate a variable by which we can solve the system. So the multiplication property of equality states that if I multiply an equation on both sides by a number, it doesn't change the sense of my equation. Say for example, I have the equation x plus 3y is equal to 12. If I multiply this equation by a constant number 2, I'm multiplying the whole equation by 2, I get an equation 2x plus 6y is equal to 24. These two equations are equivalent to each other. It doesn't change the sense of the equation, and this equation and this equation are one and the same. If I graph these two lines, I'll get the same exact line. So it doesn't change the sense of my equation. So this property is what we are going to apply when I solve my equation by elimination method and the two by multiplication. So solving by multiplying one equation. So in my system, I usually have two linear equations. So I'm going to multiply one of the equations and I change the equation to something else and use that changed equation with the other equation in the system and then apply my elimination by addition or subtraction. So that sounds all too confusing. Let's go right to the problem. Say I have these two equations in my system, 7x minus 5y equal to 17. So I have two equations, equation number 1 and equation number 2. In elimination by addition or subtraction, we wanted to eliminate the variable that had the same coefficient. The signs of the number could be same or different, doesn't matter. I wanted to concentrate on the variable that had the same coefficient. So when I look at this equation, the variables x and y, the coefficients are totally different. So I cannot straight away add these two equations or subtract these two equations to eliminate one of my variables. They won't get eliminated. But when I look closely at my variable y, it looks promising in the sense I have a 15 here and I have a 5 here. If I multiply this by 3, it is going to become a 15. So in an equation, if I multiply one term by a 15, I have to treat everybody the same. So if I'm multiplying one term, then I have to multiply the other one and also the constant number. So I'm going to take equation number to change the coefficient of my variable y to a 15. I'm taking equation number 2. I'm going to multiply it by 3. Okay, because that will change the coefficient of y to a 15. So my new equations become 21x minus 15y equal to 51. 7 times 3 is 21. Negative 5 times 3 is negative 15. 17 times 3 is 51. So I have a third equation. If I look closely, my equation 2 and equation 3 are one and the same. It just looks different, but they are one and the same. So now I'm going to bring back my first equation equal to negative 32. This is still my first equation. I did not change it. So instead of using 1 and 2, I'm going to use 3 and 1. Alright, so now this becomes my new system. And when I solve the system, the value that I get for my x and y is going to satisfy all of these equations. Okay, so let's go ahead and solve this now. I have my variable y, which has the same number but the opposite signs. So opposite number, they have become opposite number. So opposite number I add. So I add the two equations. When I add the two equations, 21 plus negative 2x, 21x plus negative 2x, 21 plus negative 2 is going to give me a 19. Negative 15y plus positive 15y, it's going to cancel out each other. That will be equal to 15 plus negative 32. Sorry, 51 plus negative 32. 51 plus negative 32 is going to give me a 19. So I have my x equal to 1. So I solved for x. So we started off with two equations. I wanted to eliminate one of the variable, but I couldn't because the coefficient of both variables were different in both of the equations. So when I looked closely at the variable y, one coefficient was 15, the other one was 5, so I could change the 5 to a 15 by multiplying the whole thing by a 3. So when I multiplied by a 3, I could change the equation. Now I bring back my equation number 1 and I solve it by elimination by addition. So I got the value of x. Remember, we have to figure out what y is also. So now I have my x value and I have three equations, not one equation, but I have three equations. Equation number 1, equation number 2, and equation number 3. So my x should satisfy all of the three equations. So if I can plug it into any one of them, it will satisfy all three equations and I can figure out what y is. So I have the first equation, negative 2 times 1 plus 15y is equal to negative 32. So negative 2 plus 15y equals negative 32. So 15y, I add a 2, 15y is equal to negative 30, or y is equal to negative 2. So I got my solution 1, negative 2. The solution is 1, negative 2. So that's elimination by multiplying one equation. So let's do another one. Say I have these two equations now. So I want to solve by elimination. I have equation number 1 and equation number 2. When I look closely, the variables x and y, the coefficients of them are totally different. I cannot just add them or subtract them and then eliminate one of the variables. But when I look closely, the variable x looks promising because that's a 2 and that's a 1. So if I multiply equation 2 by a 2, that's going to change that 1x to a 2x. But if I have to multiply this one, I have to multiply this term and also the 8 by a 2. So when I multiply equation 2 by a 2, I get 2x plus 10y equal to 16. This becomes my third equation. Now I bring back my first equation. 2x plus 3y is equal to 9. This is still my first equation. Now these two become my system, and I'm going to solve these two by elimination by addition or subtraction. So when I look at the variable, that x is the variable that I'm going to eliminate. I look at the number, it's the same number and same sign, and I'm going to subtract. So 2x minus 2x go away. 10y minus 3y is 7y. 16 minus 9 is 7. So I got my y. Y is 1. So I figured out y. Now I have to figure out what x is. I can take this y value and plug it into any one of the equations. Equation 1, equation 2, or equation 3. I can plug it into any one of them. I'll get the value of x. So I have 2x plus 3 times 1 is equal to 9. Or 2x plus 3 is equal to 9. Subtract the 3. I will get 2x equal to 6, or x is equal to 3. So my solution is 3, 1. That's solving a system by elimination method, elimination by multiplication, and that to multiplying one of the equations. So now comes elimination, solving systems by multiplying both equations. This is also elimination method, but I'm going to solve it by multiplying both equations. My video is running out of time, so I'm going to continue this in part 2.